Hi, I'm Kozicin. I will do the demonstration of this project. Firstly, this is the C code for the baseline 4x4 matrix multiplier. This is the test bench for the baseline 4x4 matrix multiplier. So I will click on the Run C simulation at the right side and click Clean Build and click OK. So from the result obtained, it can be seen that the C output is same as the golden output. Next, I will go to the project setting to make sure, go to the simulation, go to the synthesis and make sure the top function is mat multiplier. Okay, next, I will click on the C synthesis. Make sure the period is 10 and the part selection is Kintex UltraScale plus KCU 116 evaluation platform and click OK. So this one is the synthesis report obtained. From here, we can see that the estimated time is 6.5 to 1 nanosecond and the latency is 34. And this one is the resources usage. Then I will run C/RTL core simulation. I will use the Verilog and then dump trace is all and click the web debug and click OK. So it will bring me to the Vivado Xilinx and give me the output waveform. As you can see, this is the output waveform generated from the C/RTL core simulation. This one is the output waveform of the 4x4 baseline matrix multiplier. The latency is 32 cycle, which is matched with the C/RTL core simulation report. So this one is the core simulation report generated from the C/RTL core simulation. Next, I will open the Vivado software. So this one is the Vivado software. I will create a project for the baseline 4x4 matrix multiplier and add the RTL file generated from the C synthesis in BTSHLS. Please be noted that the project part using in this Vivado Xilinx is also Kintex UltraScale plus KCU 116 evaluation platform. After the first round of the synthesis and implementation, we will get the timing as not available. This is because we are not adding any timing constraint on it. So next, after the first round of synthesis and implementation, we will add the timing constraint to the design. So I'll click on Open Synthesis Design. I'll click Edit Timing Constraint and make sure the period set is 10 nanosecond and click Add Clock and Apply. So I will run synthesis. So inside the project summary, it can be seen that the synthesis is running. Next, I will run implementation to get the power, timing, and resources usage report. So as you can see in the implementation status, the status is also running. Next, we will click on View Report to view the power, timing, and resources utilization report. So as you can see here, the setup time and the hold time is positive, so no violation is occurred. From the power report, it can be seen that the dynamic power is 0.104 watt and the static power is 0.451 watt. So the total power will be 0.555 watt. From the post-implementation utilization resources table, it can be seen that there are 126 load, 88 FF, 60 FP, 192 IO, and 1 BUF2. Next, this is the optimization for the 4x4 matrix multiplier. In this design, I will use a left partition, bitwise optimization, and loop arrowing with factor equal to 2. This is because when the factor of loop arrowing is too high or combining loop arrowing with pipelining in this design will causing resources overutilization and simulation fail. This is the test bench of this optimization design. The test bench used is the same with the baseline 4x4 matrix multiplier test bench. Then the same step will be repeated as same as the baseline 4x4 matrix multiplier design. So first, I will click on the run simulation in the left side, Clean Build, and OK. So at here, it can be seen that the output obtained is same as the golden output. Then I will click on the project setting, click on the synthesis, and make sure the top function is mat_mul. Click OK, and then I will run the synthesis. Make sure the clock period is set to 10 and the part selection is set to Kintex UltraScale plus KCU 116 evaluation platform and click OK. So this is the synthesis report. The estimated time is 6.5 to 1 nanosecond, and this is the latency, and this is the resources usage. Next, I will run the C/RTL core simulation. Select the done trace and all, click the webform debug, and click OK. It will bring me to the Vivado Xilinx and give me the output waveform. As you can see, this one is the output waveform of the optimized 4x4 matrix multiplier. The latency is 17 clock cycle, which is matched with the C/RTL core simulation report. So this is the C/RTL core simulation report for the optimized design. You can see here the average latency is 17 clock cycle. Next, I will open the Vivado Xilinx software, create a project for the optimized 4x4 matrix multiplier and add the RTL file generated from the C synthesis in BTSHLS. So at the design source, I will click Add. Next, Add File. Find the file inside the synthesis, Verilog, and then add these three files inside the design source. Click OK. Please be noticed that the project part using in this design is also Kintex UltraScale plus KCU 116 evaluation platform. And then I will run the synthesis. After the first round of the synthesis and implementation, we will get the timing as not available. This is because we are not adding any timing constraint on it. So after the first round of synthesis and implementation, we will add the timing constraint to the design. So at here, I will click on edit timing constraint, make sure the by period is 10 nanoseconds and click add clock and click apply. Then I will run again the synthesis. So at the synthesis column, it can be seen that the status is running. Next, I will click on run implementation to get the timing, power, and resources usage report. As you can see, inside the implementation tab, the status is also running. After the implementation is done, we'll click on View Report to view the power, timing, and resources report. So from the timing report, it can be seen that the setup time and the hold time is positive, so no violation is occurred. Then we can see on the on-chip power. The dynamic power is 0.102 watt and the static power is 0.451 watt. So the total power used is 0.553 watt. Next is the post-implementation paper. This design is using 425 load, 310 FF12 DSP, 262 IO, and 1 BUFG. So from the result of them, it can be seen that the latency is reduced and the total execution time to complete the operation decreased. The power also decreased. However, the trade-off is the resources usage increase. That's all for my video. Thank you.